Yeah, so we were at this typical analytics architecture. So this is the analytics architecture which we generally follow to design any analytics solution. So far, do we have any question on this architecture part? Okay, move ahead.
Rahul sir, one small, it's not related as such, but how it is, this particular architecture can be deployed in the cloud infrastructure. Like,
Yes. So basically, generally, analytical solution we were deploying on premise, and yes, we can deploy on cloud. So various cloud platforms are available now, like AWS, Microsoft, Azure. Then there is a Google Cloud. There are various tools, services provided by this cloud service provider, and by integrating all those services, we can deploy a complete analytical solution on cloud. So, since as we all know, like cloud has its own benefit, since we don't have to keep any hardware, any infrastructure with us, it is completely available on cloud. Uh, yeah, so we can. So, what particular is it? Any specific question, or do you want to know like complete, basically solution end to end how we deploy in cloud? Is it any specific question on cloud?
not necessary. Is there any parallel analytical, you can say, architecture which is available currently in cloud infrastructure, something like that?
Okay, so you can search on any log processing example. So
I mean,
basically,
data warehouse, like any data warehouse which is available as a service, something like that.
so, as a open source, I couldn't recall anything since we generally develop solution for our enterprises, and for open source, uh, sorry, means I don't remember. Is there any data warehouse which is freely available and you can play around that? No, I does no. I don't think there is a open data warehouse. You can get a data sets in terms of you have to create your own data warehouse considering your own storage. You can get lots of data sets in GBs and then dump those data in your data warehouse and then you can play around that. So that way I can think of for now, but openly available for public, I don't think there is any data warehouse available.
Okay, no problem.
Yeah. So yeah, when we develop this big data analytical solution, these are the common languages we generally use. So as we know, Java, it's a high-level language. Generally, we prefer Python shell script and R language whenever we design any big data solution. Then tools, as we know, to scale our data, to store our data at petabyte scale, we use Hadoop clusters. For in-memory processing, we use Spark. For machine learning, we use R Studio. And then for any data transformation, so to convert the raw data into process format, we use some tools like Talent. And there are platforms available which give you the complete basically infrastructure to end-to-end develop this analytical solutions. So some of them is Cloudera data platform. So Cloudera stands for CDP. So initially there were two major big data platform, Hortonworks and Cloudera. So those are now merged into single one, that is Cloudera data platform. There is another platform, Mapr. Then we have AWS and then Microsoft HD Insights. So these platforms provide you all the services which you can use to utilize to develop the big data analytical solution. Yeah, any questions on tool technologies platform? Okay. Yeah, moving ahead to the applications, big data analytical solution can be applied in any sector, whichever sector generates a huge amount of data. We need this big data solution because once the data is stored at beyond the scale, beyond the limit, you cannot analyze that data or retrieve insights from it unless you apply some big data technologies on it. So to get important or useful insights from that, you have to use big data technologies. So few of the use cases I have taken, there are multiple use cases. From among the multiple, I have taken two of the use cases. So one is like in a e-commerce, generally we see multiple products on e-commerce website. So to improve the product experience, user experience, generally e-commerce have this sentimental analysis solution deployed. So whatever comments, reviews we add on the product, those are stored in a data warehouse, and then by applying appropriate algorithm on those data, a sentiment is derived. And then on deriving the sentiments, whether that product is good, bad, or neutral, we basically product owner or the e-commerce website owner takes the decision like which products to be promoted or which products needs to be removed from e-commerce website. So this is the general example which is followed on e-commerce, and this can be applied to any other solutions where free text information is given by the user. Next, yeah. Next use case is like detect the fraudulent transactions. Yeah, in banking, we generally see like most of the transaction we have, we get a success. The success rate of a banking transaction is almost 99.9%. But since there is increase in cybersecurity and all the other threats, there are chances of fraudulent transaction, and we are seeing those. So to detect those, this big data analytics comes in help. And basically what we can do is like we can create such engines which will detect the anomaly. So it is the anomaly detection algorithms we have to use. Using a machine learning algorithm, we can deploy this big data analytic solution which can detect anomalies from the general transaction. So any person who does this transaction have certain rules specified for them. And if the transaction is considered as an outlier, the the it passes through general rules. But if it is passed, it is considered as an outlier. Then this algorithm will detect the outlier and alert to the end user that this is the outlier. In such cases, the application user can consider like this is some fraudulent transaction, and then he can investigate on that and uh, do the action appropriately on it. So this is the simple use case, but when it comes to scale, around thousands or you can say millions of transactions are happening in day, and to detect outlier from these millions of transactions, we need these big data systems. We have to process in this data in memory, because we need this insight on real time. So there are solutions like Apache Spark, which we can scale to process around GBs of data in memory and detect outliers from them and get the fraudulent transaction. Yeah, any questions so far? Yes, I think I'm done with the big data analytics overview. I guess if you have any questions around the big data analytics or any terms you need to understand, you feel free to ask any question. Next, we will move to Hadoop internals and architecture. Before that, we can take any question on big data analytics.
Are there any, hello sir, are there any data sets which are in large big data kind of like in GBs or TBs available currently?
Yes, yes, we have this Wikipedia database available completely. I guess it is in GBs.
Okay.
Yeah. Okay. Yeah, any further question? Shall I move to next slide, next presentation? Okay, I will move to next. Is my screen visible?
Yes, sir.
Okay, just a minute. Yeah. So yeah, we talked about this big data, some concepts of big data, uh, what is analytics, then what are the use cases, then how we do the analytics using CRISP model, using machine learning. So these are the concept technologies and terminologies which are involved in big data analytics. Now we will focus on the actual technology which actually takes data, process data, and then derive result. So that's the complete picture of this Apache Hadoop. So Apache Hadoop is being an open source project. Initially, it started as a crawler in I think 2002, and then it evolved. And current version is I think Apache Hadoop 3.1 plus. So it is an open source software used for distributed computing. Since it is termed as distributed computing because we can run a single job on multiple machine. Therefore it is called as distributed computing. We can also term it as parallel computing. It is a library which allows you to process large data set using simple programming models. When I say programming model, program can be either in Java, Python, or shell script. It is designed to scale up from single server to thousands of machines, and each offering local computation and storage. Apache Hadoop can be scaled from single node cluster to as we require. So as we if we see like there is increase in data, we can add new node in the Apache Hadoop, and we can scale in that way. So in Hadoop, data is processed on each node. The computation is performed on each node. Instead, it is not done on a single machine. It is done on a distributed fashion. The library is able to detect failures, and also it is highly available. So when we say it is highly available, uh, any so for example, we have deployed an Hadoop cluster with the 4 nodes, and we have submitted one job on Hadoop. So if one of the node fails out of 4, 3 are there, it automatically switches to 3 node. It will not give you an error while submitting your Hadoop job. So that's like highly available. Yeah, this is this talks about the evaluation. It started in 2002, then Google published a paper for GFS, then a map reduce, and then Hadoop 0.1 was born in 2006. I think you can go through this. So till now, Apache mostly it is developed and maintained by Cloudera and Hortonworks community. Yeah, these are the some of the features of Hadoop. So scale out architecture. So scale out, as we earlier discussed, it can be scaled at any scale. And you add a new machine, it will scale out. Highly available, yes, it is highly available. Uh, we can basically have auto scaling and basically uh, uh, failure. We can fault or make it as fault tolerance, because any error occurred, it will automatically recover itself. So that's the property of fault tolerance. Flexible access, yeah. Since our Apache Hadoop is written in Java, we can integrate with other programming languages also, with other frameworks also. Load balancing is there. We can increase or decrease the load as the traffic increases for the data. Replication, this is very important aspect when we say talk about the data. So each copy of data which is termed as a block in Hadoop is stored as in 3 different places. So if any one place get disturbed or it is damaged, we can recover your data from other 2 places. So that is called a replication factor, and we can configure this replication factor in Apache Hadoop. Then security. So security is very on a granular level. So if you have used Linux systems and there is a POSIX like security, uh, read, write, execute. So we can apply security at granular level on particular file which is stored on Hadoop file system. Yeah, and this last is large file. Yes, Hadoop is designed for very large files. It should not be used for small files. So if, for example, if you have 100 kbs of file for thousands of 100 kb of file, it is better to not use Hadoop for it. But if you have 100 MB of file in thousand and number, then it is better to use Hadoop. So in that way, big files in big size should be, uh, in that case, we should use Apache Hadoop. Unnecessarily, if we use Apache Hadoop for small size file, then the hardware and the infrastructure cost will be increased. Yeah. So currently we are using Hadoop 2. Earlier there was Hadoop 1. So Hadoop 1 has the core engine behind Hadoop 1 was MapReduce. MapReduce is an basically cluster resource management framework. So whenever a job is submitted, when Hadoop, suppose I want to store a text file on a Hadoop file system. So what it will go, it will when I submit this file, it will first execute the MapReduce job. uh, it will convert that data into reduced format and then store in the Hadoop file system. That is a bit slow and it takes some time. It is not as that real time since Hadoop is made for batch oriented systems. This is overcome in Hadoop 2.0 since the cluster resource management is covered by YARN. So YARN stands for yet another resource management node. So that is improved drastically in Hadoop 2. We are using execution engine as a Thales instead of MapReduce. So there is drastic improvement in performance. Read write operation which are done on Hadoop file system are improved. So if you see this pig hive, then there are edge base. So pig is the scripting language which is used to retrieve data from Hadoop file system. Hive is SQL over Hadoop.
Hello, hello. So please wait for few minutes.
Yeah, sorry, I got disconnected. My Wi-Fi has gone down. Yeah, can you tell me from where I got disconnected? I will share my screen.
Yes. Okay, I can please see that.
Not able to.
What is what? इधर रिक्वेस्ट सुभाषी अटेंडेंस को नहीं फीडबैक पे आना करना पोर्टल पर होंगे है ना
I'm not getting this share option visible now.
आता तर केलं होतं त्यांनी आपण नाही करू शकतो ना तो तिथे करणार आहे
Yes. Is my screen visible now?
Yes, sir.
Okay. Okay. Sorry for interrupt. Uh, okay. So we were at Hadoop 2 architecture.
Yeah, you can start from this side.
Okay. So yeah. So Hadoop, when we see Hadoop, like Hadoop is have basic two components. Whenever we deploy on Hadoop cluster, uh, let's consider a four-node Hadoop cluster. So on four-node Hadoop cluster, the major components are name node and data node. So name node is the single point of failure, which is basically is a first point of contact for a client which submits a request to retrieve data from Hadoop file system. So whenever a client sends a request to retrieve a data from Hadoop file system, first it comes to name node. So name node is a centralized manager which stores the metadata for each of the data node, data stored in Google Hadoop file system. So suppose I have stored my x.txt on Hadoop file system. So what it will do, it will can you go on mute? Anyone? I'm getting background noise. Can you go on mute? I'm getting background noise. Yes, it is better now. Thank you. Yeah. If we store, for example, a sample.txt on a Hadoop file system, so first that txt, basically a request will go to name node. That name node will check where that actual what is the physical location where actually that file is stored. It will try to retrieve the best shortest path for it. Since we have replication factor of 3, it would be stored in a 3 different machines. When we see because that replication factor is 3, it will be stored in 3 different location. Then it will the request will go to the node manager. So node manager is installed on each of the data nodes. Manager is responsible for retrieving the data from actual location, that the file directory, and then it will send to the client. So this is the flow of basic read write operation which we perform on HDFS. In Hadoop one, there was a name node was single point of failure. In Hadoop 2, we have a secondary name node. So if at any instant, suppose name node crashes, it will automatically recover itself and switch to the secondary name node. Then there were job trackers and task tracker. So those were not that has been replaced by node manager in Hadoop 2. Also, yarn is introduced in Hadoop 2. This yarn allows you the federated processing. So federated processing, in when I say we can have your storage locations at different geographical location, though yarn is able to find the best possible location and retrieve data. So yarn is very flexible. Uh, it is uh, it is more we can say as it has a more performant, because earlier in Hadoop one there was MapReduce. So MapReduce takes lot of time for computation processing, whereas yarn we can scale out by giving the appropriate memory to yarn configuration. It is more performant. So that is major improvement. The node manager, then name node, addition of active secondary name node, and this yarn. So that has improved yarn Hadoop 2 in a better way. So earlier Hadoop was seemed to be as a batch oriented. It takes a lot of time to read and write files from Hadoop file system, but now it performs better. Yeah, any questions on this Hadoop architecture? So any component you want to understand?
Yes, sir. Sir, I just wanted to, as you said, like Hadoop 1 and Hadoop 2 architecture. So in that, like mapper basically has different phases, right? Mapper and the reducer phase. So how about the
Hmm.
yarn? Like, does it contain that mapper reducer phase, or how it
No,
is
no,
different
it
than?
doesn't contain this map reduce. It is so yarn architecture basically internally the code is map reduce only, but they have improved added few algorithms which has improved its performance. I think if you want more details about it, you can go through Apache Hadoop Yarn official website. There you can get more details on that.
Okay, but then it is not a replacement for mapper, right? So map reduce.
No, it is replacement in case of Hadoop 2. So basically, the execution engine in case of Hadoop 1 was MapReduce. And then they worked on this MapReduce framework and tried to make it more performant. And that is replaced by Yarn. So execution engine is replaced to Yarn in case of Hadoop 2.
Okay.
Hello?
Okay, sir.
Okay, does this make sense to you?
Yeah, but I'm not able to see the slides. I don't know whether I am. Is it my fault at my end, or
It is shared from my end. It is shared from my end.
okay, probably at my end I'm not able. At only it has gone out. Okay, sir. No problem. Thank you.
Visible button on
Yeah,
Uh,
so the one flow which I described, this is the actual granular flow. So whenever a client sends a request, it goes to first name node, it reads the metadata, and then name node read passes this information to data nodes where the node managers are installed, and it retrieves actual blocks. So the actual information is stored in a blocks. So we can define we can define a size of block in basically Hadoop configuration. Default size is 128 MB. We can scale up to 256 and more. So as per the data needs. And then once the data is read from data block, it sends to the client. This is the basic block flow. Yeah, I have tried to add a simple picture which describes about the map reduce framework. So basically, in simple terms, if we say what is MapReduce, so MapReduce is just like any unstructured data, we have to make it as more structured. We use MapReduce. So in this example, if you see, we have a sequential information like apple, orange, mango. These are space separated tuples, and then you have to get a proper structured information from that. So to get that, what we do, MapReduce have certain functions in that, like shuffling, sorting, and then reduce it to the final output. So what it does is first it map input file is first it is processed line by line or space by space or delimiter space. So we can read file line by line, or we can specify like delimiter by space separated, comma separated, semicolon separate, etc. So when we read line by line, we get each line, then we split the key value, then we sort and shuffle according to their categories, and then we reduce it to the uh, final output. Basically, merge it to the final output. So I think this is the basic phase through which MapReduce goes. MapReduce, we can write this MapReduce job in Java. Uh, there are various libraries available. Either we can use through Python, or we can use Java library for this. Uh, Generally, this since this MapReduce takes time to execute your job, it is replaced nowadays by Spark, since it is more performant. But yes, MapReduce will be stay, since the Hadoop underlying architecture consists of MapReduce, and it will support till the Hadoop is there. So MapReduce will be there. But as a practice on solutions front, we generally tend to not use MapReduce. Yeah, so these are the few commands when we use to retrieve data from Hadoop. So like if you have used Linux file system, there are ls command to list all file, there is cat command to show the contents of file. Then there is, we can copy data from local file system to Hadoop file system, or we can copy vice versa from Hadoop file system to local system. So all the operating system command which we generally get in any file system that are mostly are supported. There might be some which won't be supported, but basic operation which we generally perform on files and folders, those are all supported by Hadoop file system. Yeah, these are the few references through which you can actually go through installing a single node cluster and play around it. You can store some data, useful data on this Hadoop, and yeah, basically you can deploy your analytical solution by ingesting data and then retrieving useful insights from that. Yeah, so this is the basic Hadoop architecture and its usage. Yeah, I think any questions you have more towards the application point of view, how things are work and all, yeah, feel free to ask any question.
Sir, I have a small doubt actually.
Mhm.
When you talk about replication, so if
Mhm.
replication factor is 3, does
Mhm.
that mean original copy plus 3, or it is in total 3?
In total, three.
That means the replication will be 2. Like, I mean, there will be two more blocks which will be replicated of original block.
Yeah, so when I say replication of factor equal to 3, so when I consider as 3 data nodes, so the Hadoop cluster includes name node and data nodes. So data nodes, 3 data nodes, when I say data node, these are 3 separate physical machines, and each physical machine has its own storage, its own separate hard drive. So therefore, that replication factor 3 means 3 different uh, physical machine. I think from that perspective. So
So actually, duplicate copies will be 2 in that case, and or like there will be in total 3 means duplicate copies will be 2.
yes, yes, correct. Yeah, any
Sir,
more question?
yeah, yeah. Does AWS micro instances does support
Mhm.
Hadoop cluster? I mean, like if you wanted to install Hadoop on micro instances.
I will not prefer to use micro instances because it will not be that useful to work on that because it will minimum require I think 4 GB of RAM and 20 to 50 GB of hard disks. So micro won't be support that configuration.
So for Hadoop cluster,
Hmm.
how do we get the support from cloud? And if I wanted to deploy it on cloud, and that to free of cost, something like that. That solution.
No, I don't think Hadoop is available free. For on cloud, basically, we don't have
Yeah,
free.
I thought
On,
that like if infrastructure as a service if we use from AWS and we can
Mhm.
install the Hadoop cluster,
Mhm.
then will it
Yeah,
be
we
possible?
can
But as
do
you said, yeah,
correct,
but
correct. Your point is correct. You can deploy Hadoop cluster on cloud, but those are not free. Everything is chargeable on cloud.
okay, okay, thank you, sir. So is there any environment we can simulate this Hadoop completely?
Yeah, we can do it on on-premise. We can have a few VMs installed on our on-premise environment, and we can create a single node Hadoop cluster or two nodes, three node Hadoop cluster.
Okay, sir. Okay, no problem. Thank you.
And it is better to install Hadoop on Linux systems only instead of Windows and other OS X or all, because inherently Hadoop supports Linux well. It is compatible more than other operating systems.
Suppose I have three nodes, data nodes, and
Mhm.
I wanted fourth data node to
Mhm.
be suppose
Mhm.
in case the out of three nodes one node is not performing well, so
Mhm.
I want that fourth node to be active. But then
Mhm.
suppose if I have a cluster of four nodes only, so is there any scalable possibility that it can
Yes, yes,
scale that cluster?
that's the feature of Hadoop, right? It is highly
No,
scalable.
I don't have more than four machines in that case.
Yeah, so if you don't have more than four machines and you
Oh,
have to limit your processing then. So suppose you are processing 1 GB of data and that is able to process through four node, then it is fine. But then tomorrow comes you have 10 GB of data. So then your 4 GB, four node machine will not help you. You have to increase the capacity. So that how you have to increase the nodes and then capacity, basically the engine capacity will increase and you can process 10 GB of data.
So elastic Hadoop is not a concept which we can use at our premises on premise.
Yeah, that we have to do manually in case of on-premise. In case of cloud also, we have to do manually. We can configure it as elastic, but we have to do some manual configuration. That's for sure.
So elastic Hadoop cannot be deployed on using virtual machine or something like that.
I think that is like reinventing the wheel. That we can do, but it is like complete research part we have to do and work on that. Because since we have that already available on cloud, elastic nature of cloud Hadoop system, we have to do some configuration which allows us to do elastic nature. I mean, enable the elastic nature, and that type of infrastructure also we have to first set up, and then we can do this elastic nature.
Mhm. No, at a premise we can have four instead of four. I can have six machines, and I
Mhm.
can have provision for two machines, but whenever needed, like it's
Yeah, yeah,
like
that you can do. That you can do. That you can do. Yeah, so I understand now. So you have six machine, you are using four, and then you have configured elastic, and then you need to switch to five and six. So that you
yes,
can
yes.
do. That is for sure. Yeah.
Yeah, sir. Is it possible to get your contact so that I can send an email and discuss with you further in that matter?
Yes, yes, that's fine. Okay. Yeah, so if there are no more questions, we can wrap up this. It is good if you have any more question.
Sir,
Uh,
can you provide your email ID in chat so that we can just take
yes,
it
yes,
down?
that's fine. I will send. Okay. Yeah, thank you everyone. So it was nice. I would be more happy if there are more questions. I hope I could try to bridge the gap. If whatever notions you have about the big data and the Hadoop. Yeah, thank you.
Hello. Very good afternoon to one and all. I would like to thank Mr. Rahul Dhote from Persistent Systems Limited for nicely delivered talk on big data analytics and Apache Hadoop. Also, I would like to thanks Persistent to provided us a good speakers, good experts for our faculty development program. Uh, Again, as per the 5-day FDP on high performance computing using parallel distributed cloud computing. So now it's the time to conclude our program. So on the behalf of Department of Information Technology, I would like to thank all my dear participants. We have successfully attended all the 14 sessions of our FDP program. 13 technical sessions and followed by one session on life management as per as the suggestions from All India Council for Technical Education. So they required to conduct one session on life management. Uh, as far as again a requirement of Atal AICT is concerned, each and every participant has to give feedback on Atal AICT portal, right? And also give attendance, right? So again, we have maintained attendance for each and every sessions of our FDP program, and also give attendance and feedback on Atal AICT portal. Next one is again as per the AICT requirement is concerned, each and every participant has to give a test. So I think so immediately after this concluding program, all the participants should give a test on a Google form, right? So anybody have any doubt during appearing or examination? So kindly put into a chat window or on a group of our WhatsApp group, right? So thank you one and all. And also I thanks to Tata Consultancy Services from which they have provided us a expert Mr. Aditya Purohit and then Mr. Saurabh Barve and Rahul Dhote is from Persistent. Then also thanks to Mr. Moresh Kashikar He has delivered a talk on cloud providers, which covers Amazon Web Services, Google App Engine, and Microsoft Azure. Also, thanks to Mr. Akash Wankhede, he has delivered a talk on development of application using a Salesforce. Then I would like to thank Mr. Vikas Sawan from IIT Roorkee, and he has delivered a talk on virtualization with a practical demo, and also covered a case study. Also, I would like to thank Dr. Umesh Deshpande sir, a professor and head Department of Computer Science and Engineering, VNIT Nagpur, for nicely delivered a talk on introduction to fault tolerance in distributed system. Then, thanks to Dr. S.R. Sate sir, professor in the Department of Computer Science and Engineering, VNIT Nagpur, for deliver a talk on dependence analysis and parallelization. Next one, I would like to thank Dr. Jitendra Temurni from Triple IT Nagpur, and he has delivered a talk on programming using OpenMP and MPI. Right. Lastly, I would like to thank Dr. Pallavi Rathod. He has delivered a talk on light management. Lastly, I would like to thank all my colleague members of my faculty development program, Mr. Shailendra Shande sir, Chauhan sir, then Amol Gaikwad sir, Bhushan Bhavnkar sir, and Jaiswal madam for nicely organize this event for 5 days program and also conducting each and every session nicely. Right. So again, at last, I thanks to all the participants who have shown an interest in our faculty development program on SPC PDC 2 and also patiently attended all the sessions. So this is my humble request to all the participants to give a feedback on Atal AICT portal and also appear for test, because the test and attendance and feedback is a mandatory for Atal AICT for giving a certification.
Sir, one request. Actually, can we get the all 5 days recordings like in
Yeah,
anywhere?
definitely. We will share our video recordings of all these 14 sessions with you people.
Yeah, and sir, about the feedback link you will be providing and test link you will be test
Yeah,
link you will be providing on email or like
Google, yeah. So
test
also
link. Yeah.
providing on an email and also on a WhatsApp group, right?
Yeah, sir, I am
So
not in a
immediately,
WhatsApp. Actually. Yeah, yeah.
yeah, okay, doesn't
Yes, sir.
matter. So
Thank you, sir.
immediately within a few minutes, we'll start our examination, right? So after finishing on examination, you should go for a feedback on Atal portal, right?
Sir,
Yeah.
actually, I just want to know what is the test timing and how much time we'll have to complete the test.
We have a question paper is of multiple choice question and which consisting of 50 questions, and the 50 questions is based on introduction to cloud computing. Some question is on distributed systems.
No, no,
Some
sir.
few questions
No,
on
sir. Rajesh sir,
uh,
we can we have all the knowledge about the examination. Just because of, for example, I have another meeting at this time, so I just want to know how many time I have to complete this paper. How much time?
again, so what happened? Our question paper is consisting of 50 questions and time duration is again of 50 minutes. Suppose you are able to complete within 30 or 40 minutes, doesn't matter. So
Okay, so
depends on you.
can we complete our
Time
paper
on
by
the
evening?
yeah. Hello.
Can
Hello.
can I complete my paper by 2 p.m. or 3 p.m.?
Suppose within a 5 minutes we will start our test. Now it is 1:10, so time up to 2 o'clock. So you should finish by before 2 o'clock. Doesn't matter.
Okay, sir. Okay, thank you.
Yeah. So we will send our Google form. Yeah. So thank you one and all.
Thank you one and all. I am Sushil Chavan here, committee member of this workshop. We are organizing the same workshop but in detail with the series. Firstly, we are going to cover Salesforce or cloud. After that, we are organizing the parallelization in the second series. And in third one, we are going for the big data and analytics. We are organizing these three workshop series in the next month. So if anyone is interested to join for this one, please email us or give the consent for the same.
Hello, hello, my dear participants. We have got a sponsorship for short-term training program on this high-performance computing domain. So, in which earlier sponsorship was for physical presence of participant, but because of COVID-19 pandemic, so it is difficult to arrange in a physical mode. So, AICT has sanctioned this STTP in an online mode. So they suggested us to organize three STTPs on the same topic. So we are planning to organize these three STTPs on high performance computing in the month of December. So your colleague or anybody is interested to attend this. So again, I will send you an invitation for this free STTP program on HPC. And if suppose anybody is interested, so kindly register for the STTP program. Right?
Okay.
So this test in the form of Google form is available. The link is available on your mail ID as well as in a WhatsApp group.
Okay.
मेरे को टकराया।
No.